In this question, we're given a table of values for x and y, and we're being told that y is inversely proportional to the square of x. Now, because y is inversely proportional to the square of x, we're going to write the equation y equals to k divided by x squared. Whenever you see inversely proportional, you're dividing your constant by the other variable. Okay, part A says, find an equation for y in terms of x. And this equation is not your answer because it has an unknown constant. We need to find k to be able to write the final equation. Okay, now how do we find k? Well, we need x and y to find k. We can't have three unknowns to find one of them. We need to have a pair of two known values. In this case, we need to know an x and y to be able to find k. Where do we get the x and y from? Well, we have a table of values. In this table of values, we've got four pairs: 1, 2, 3, and 4. Now, which pair do we pick to find k? We can use any one of those four pairs, but for ease, we try to avoid any fractional pairs. So these two are fractional pairs because they have a fractional or mixed numbers value in them. Okay, so which pair do we pick then? We will pick, now we could pick 1, 9, and we could pick 3 and 1. In this case, I'll go ahead with 3 and 1. Okay, so if we pick 3 and 1, the x value we have is 3 and the y value is 1. So we'll write 1 equals to k over 3 squared. Okay, so this becomes 1 equals to k over 3 squared, which is 9. To find k, we need to get rid of the 9, because if we get rid of the 9, we'll have k by itself. Now, notice that k is being divided by 9, so we'll do the opposite operation, which is to times by 9 on both sides. Okay, so in this case, we will get 9 times 1, which is 9, and k just by itself, because 9 and 9 cancel out. So k equals to 9. If k equals to 9, then we can write the final equation as y equals to 9 over x squared. And that's your final answer. Now for part B, find the positive value of x when y equals to 16. Okay, so what is the x value when y equals to 16? We'll use the same equation that we found in part A to work this out. So the equation we have is y equals to 9 over x squared, and we are given that y equals to 16, and we need to find x. We'll put 16 in place of y, so this becomes 16 equals to 9 over x squared. And to find x, all we have to do is rearrange. Okay, now we can see that this is a fraction on the right side, and on the left side, there's no fraction. But we can rewrite this as a fraction by putting a 1 underneath it, because 16 is the same as 16 over 1. So now that we have two fractions on either side, we can do cross multiplication to get the x on as a numerator. So what we get here is 16x squared equals to 9. Now to find x, we need to get rid of two things. So we need to get rid of the 16, and we need to get rid of the square. Okay, so in this case, we'll get rid of the 16 first. Okay, so what we have to do is divide 16 on both sides. When we do that, we get x squared on the left side, because 16 divided by 16 is just 1, and 9 divided by 16, which is just 9 over 16. All right, so we got rid of the 16, now we need to get rid of the square. So let's get rid of the square. To get rid of the square, we do the opposite operation, which is to take the square root on both sides, and we do it on both sides, of course. So square and square root cancel out, and we are left with just x. So x equals to, now square root of 9 over 16 would be square root of 9, which is 3, over square root of 16, which is 4. Okay, they're saying find the positive value of x. So 3 over 4 is a positive value. But why do they have to say this? Why do they have to specify to find a positive value? The reason is because when we take the square root on both sides, we typically put plus and minus outside. But in this case, because we're only concerned with positive value, we don't need to put plus and minus outside, and we just take the square root of the number as is. And this is our final answer.